Natalie Tarry here from Natematics. I'm here to take you through a few different circle theorems questions. Here is the first one. So find the angle OPT. Now, when I'm going through some of these questions, what I may do is come at it from a, not just here is a circle theorem question, but here is an exam question. What's in the question? What could be quite useful? What have I got to look out for that might help me to decide what's actually going to be used in the question? So let's have a look at this. So OPT, definitely highly recommend you get some highlighter pens and then highlight the actual angle that it is we're finding. So OPT, so it means going from O to P to T, and you will have an angle in the middle, which is this one here. Now, I'm coming at this from the premise that you don't know how to do this. So I'm going to give you some thoughts as to how you can work it out. So, well, what can we see in this question? Well, we've got these things with little arrows on, which mean that they are parallel to each other. So straight away, that should be thinking, okay, well, what does parallel lines mean in the context of angles? What might be useful? What do I need to remember? Okay, point number one. Point number two, we have a line here, which is a tangent. It's a line that touches the circle at some point on the circumference being basically the outside of the circle. We also have O, we've got a centre, there's a dot there, so we know that's the centre of the circle. So therefore this distance here that's the radius. Just in case you get confused, hopefully you don't at this point. If you're doing circle theorems, I'd like to, we've got a good grasp of circles, but remember the diameter is the chord that goes across the centre of the circle. The radius is half of it. It goes from the centre to the outside. Okay, so parallel lines. Well, hopefully by now you'll have thought, well, yeah, there's those angle things, isn't there? Like F and Z and X and C. Now, the shapes are fab for helping you to remember them, but you also have to remember the names, because quite often on these questions, you're asked to give a reason. So parallel lines, well, we have alternate angles. We've got corresponding angles. We also have co-interior angles. So are there any of those here in this question? Well, I can see an alternate angle. It's the Z shape. Now I'm going to highlight it here. And again, highlighter pens are so useful. Now, if you were to find the Z shape using two of the lines which are parallel, and you've got what we call the transversal, the line that goes between them, any line that goes between them, those two angles are equal. So we've straight away found that TOP, that angle is 58 degrees. Because alternate angles are equal. Okay, so what else have we got here? Well, we've got the tangent and we've got the radius again. What's the connection between tangent and radius within a circle? It's one of the circle theorems. It's the tangent meets the circle. The tangent meets the radius of the circle at a right angle. Right angle? 90 degrees. Now, obviously, it's slightly out on there, but forgive me for that little adjustment in my editing. Okay, so if that's 90 degrees, you can see here that we have a triangle. Angles in a triangle add to 180. So therefore, we know that this angle and that one's going to add to 90 because that's 90. So therefore, that angle there, which is what we're asked for, is 22 degrees.